Hey, party people. People who love to party. It's me, Mr. Bill, here to talk to you today about negative exponents. We're going to unlock that secret that we kind of got to the last time we were talking. So, negative exponents. What do they even mean? You can see this problem right here, and I know you know how to do it because when we times like bases together, we add exponents. 2 plus negative 3 is going to be negative 1. This is x to the negative 1 power. And frankly, is that okay? What does it even mean? And to demonstrate that, I'm going to recreate something that I would normally do in a classroom, which is to set up some lists of stuff and start getting some values and work with our pattern recognition skills to get to what exactly these things are. Because we want a solid understanding, and there's lots of little ways to get lost. You'll see that even as we continue on. But as we get into this, first thing I need you to do is know what 3 to the first power is. Folks, that is 3. And 3 squared is 3 times 3, which is 9. And 3 cubed is 3 times 3 times 3, which is 27. And 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. And if I wanted to ascend this pattern, that means I want it to go up without necessarily having to do these in-between steps. I just want to know, how do I get from 3 to 9? The obvious answer is times by 3, because that's what happened here. You got times by a 3. And if I want to get from 9 to 27, how do I do that? Well, we would times by 3. Well, if I want to get from 27 to 81, well, we would times by 3. The big deal with this isn't the going up, because the up is the intuitive part. The big deal is going back down, because if we can start at the top and go all the way back down, we've got to feel certain, or at least confident, that what we're dealing with is logical, that it makes sense, and that's what it is. So check it out. If I want to get down from 81 to 27, I'm just going to undo this thing right here. And how do you undo a times 3? You divide by 3. That would get you 27. From 27 to 9, well, I would need to divide 27 by 3 to get back down to 9. I know about now you're like, this is dumb. Trust me, well, I mean, maybe it is though. I don't know. But I've done this before and it's worked. If I want to get from 9 down to 3, I divide by 3. And the kicker, if I want to get down from 3 to the 1 power, down to 3 to the 0 power, I'm going to divide by 3. What is 3 divided by 3? It's 1. And I can do it again to get to 3 to the negative 1 power. What does that even mean? It's just 1 divided by 3, or a third. I can divide again. Now I'm dividing by 2 3s. Well, 3 times 3 makes 1/9. I divide again by 3. 1/27th. And again, 1/81st. Now, this makes something that is almost symmetrical. And actually, it is very symmetrical. You may be looking at this one, you're like 3 and 1/3. Oh, yeah, they almost look like each other. 9 and 1/9. Oh, yeah, almost. No, not almost. Exactly. 3 over 1 is what 3 is. 9 over 1 is what 9 is. 27 over 1 is what 27 is. 81 over 1 is what 81 is. So they are exactly flipped upside down. So, does this happen all the time? Absolutely it does. Watch, we can quickly do it with 5s. 5 to the 1 is 5. 5 squared is 25. 5 to the third is 125. 5 to the fourth is 625. Easy to ascend. You're timesing by 5 going up. Well, what if you want to go down? You would divide by 5. Divide by 5. Divide by 5. And 5 divided by 5 is 1. That's why anything to the 0 power is 1, because you're effectively dividing it by itself. After that, divide it by 5 and you get, ta-da, 1/5. Do it again and you get 1/25th, 1/125th, and 1/625th. Voila. Now there's an extra piece that we can get from this, and that is that 25 is actually 5 squared. Ah, and this is 5 to the third, and this is 5 to the fourth. Hopefully that makes sense because we're going to use it later. But this is also where a little bit of skip in logic happens. And I'm going to see if I can iron that out by giving you a couple more problems. In problems, we're going to start easy, but as you can see, it's going to get more difficult as we go along. If I've got just standard y to the second over y to the fifth, I could do the y to the 2 minus 5, and that's going to equal y to the negative third. That is not an appropriate math answer. Just like 3 to the negative third wouldn't be appropriate. I'd expect you to write 1/27th. 5 to the negative third wouldn't be appropriate. I'd expect you to write 1 over 125 or 1 over 5 to the third power. So this is 1 over y to the third power. That's the answer. This is an answer. That's the one we want in our math class. Here, let's try some more. So an answer we could get here, we could distribute this power to our other powers and get a to the negative eighth times b to the negative 12th. Not going to work. We do not want negative exponents in our answers. We want to convert those. A to the negative eighth is going to convert to 1 over a to the eighth. B to the negative 12th is 1 over b to the 12th. And the sign in between them that we never ever wrote was multiply. So I get to join those ones together. And these folks all get to party on the bottom. Yeah. There you go. That's the appropriate answer. Now, this guy is the key to the castle. You've got 1 over b to the negative third. Well, we never dealt with the negative being on the bottom. Yeah, guess what? It just moves to the top. So that 1 is still up there. I'm going to move b to the third up here now. Ding. Now it makes sense. Now you may be thinking to yourself, that doesn't make sense to me. Guys, anything on the bottom, like this a to the eighth, that's really a to the negative eighth. So if this was b to the negative third, it's really b to the negative third. Hence why it gets to move up. In its place is left a 1. Well, that's a whole lot of 1s in here doing nothing. This is just b to the third power. I can just pick it up and put it on top now. It's good to go. So what happens when you put that negative out in front of a fraction? Well, we can use our power rule to begin with. This would be r to the first, negative 2 times 1, negative 2 times 5. You have r to the negative 2 over t to the negative 10th. But we just figured this out over here with b to the negative third on the bottom. 1 over b to the third was just b to the third. It changed places within the fraction. So I'm just going to change these guys' places. T to the 10th, bam, negative resolved. R to the second, negative resolved. We're done. We did it. You may notice this is the same as if you had flipped it upside down in the first place to resolve this negative, then took the times 2 power to both the top and the bottom. And that's exactly what you want to do with a more difficult question like this. In this question, we can actually go inside and resolve something first. You see that f to the negative third power? I don't want that there. It doesn't want to be up top anyway, so we're going to move it down. We've got 5 over f to the third, g to the fourth, and all that to the negative 2 power. Wait, what is that big negative going to do on the outside? Well, what we saw it do here is we flip everything upside down. Oh my God, no, wait. F to the third, g to the fourth over 5 to the second power. I've now used up the negative sign. You could distribute that negative 2 to all the powers if you wanted to. The same thing is going to happen as what I just did. Now, we're finally going to get that 2 to all the powers. Remember, that 5 has a power of 1. So this is f to the 6th, g to the 8th over 25. 5 squared is 25, y'all. That should not be news. All right, lastly, look at that. So complicated. Folks, take it a piece at a time. Remember, you're going from top to bottom. If you look at this, you see this 4. That's a regular number. So we're going to have to deal with it like it's a regular fraction. There's no regular number down here, but there's a 12 right there. 4 over 12, if you were to reduce it as a fraction, would be 1/3. Now let's move on to the x's. I've got x to the third and x to the seventh. They're going to subtract. I'm going to get x to the fourth on the bottom or x to the negative fourth on top. I don't want to do that extra step. So I'm just going to say 3 minus 7, 4, negative 4. So put it on the bottom, x to the fourth. Mr. Bill, I want a negative on the x to the fourth on the bottom. No. X to the negative fourth would move it to the bottom, and that would resolve the negative sign. I mean, doesn't that make sense? There's more x's on the bottom than there are on the top anyway. Get out of my face. Okay, now the last part. We've got y, and this y to the negative fourth, it doesn't even want to be down there. It wants to move up. But Mr. Pugh, what's the math that's going on with that? The math that's going on is this. Y to the first minus negative 4 would be y to the first plus 4, which is y to the fifth. These 4 y's went up and joined this other y. They were like bases, so we added those exponents. And this would be y to the fifth over 3x to the fourth. I know you can tell I'm excited about talking about these exponents. Negative exponents are one of my favorite things. I'm just a weird guy. I don't know what to tell you. Your job, whether you choose to accept it or not, is to try these problems, and I will check them with you before you are released to do even more problems. These are tough problems for giant robots with claws for hands. There's 1, 2, and let's zoom out a little bit and see if we can sneak in 3. I know those letters are small. I'm trying to hold it there for you for a second. So maybe if you pause your video, you can see some stuff. And then these guys down here. We got 4. Because I know not all of you print out the stuff as you go. I do not require you to have a printer. I'm not trying to change the way you and your family live your life. But you do need to get this work done. All right, I'm going to pause it. Next time you see me, like in a second, there will be answers up here. My face will look somewhat different than it does right now. Ta and da. See? Told you. All right. I had to zoom out to make sure that all my answers fit, but hopefully you can understand the work. Divide it up this way. Needs to be an equal sign there and an equal sign right here because it flows down to that word. Please take a healthy look at all that good stuff right there. And then down here, I got even better about doing my work as I went on. At first, I just wanted to write the answer down because I can do these things in my head. You know, got a hold of myself, did the thing I needed to do, get those answered right there. Folks, if you've got questions about this, then you better ask them to me at some point in time. But until then, stay safe. World crazy.